Okay, so now let's go over a couple of examples and see if we understand statements. So for example, let's say that you say 8 is less than 6. 8 is less than 6. So about this statement, of course, the sentence is false. So you can say that the sentence is false. It's very easy to decide that the sentence is false, and therefore you can call it a statement. There is no problem with that. You can call it a statement. Now, suppose that you say, for example, every set is a finite set. Every set is a finite set. Of course, you know that there are also infinite sets, so that makes this sentence false, and so you can call it a false statement. You can call it a statement. So this you can also call a statement. Suppose that you say, for example, the sun is a star. The sun is a star. Well, I suppose, of course, I don't have any sort of extensive knowledge about astronomy and that sort of thing, but I suppose this statement is true, or this sentence is true. It's a scientifically established fact that sun is a star, and therefore this sentence is always true. Hence it's a statement. So, of course, you can. I mean, scientific facts. Of course, you can use them as a part of your reasoning, and since it scientifically has been established that sun is a star, therefore this becomes a true sentence, and therefore this becomes a statement. Now, number 4. Suppose that I say that, for example, mathematics is fun. Well, the problem with this sentence is that there is difference of opinion about this sentence. Some people are of the opinion that basically mathematics is fun. Some people hate mathematics. Some people don't like it. Some people, I don't know, they don't like it, but they think that, well, since it's something that you have to study, so there is no point in whether liking it or disliking it. You just have to do it. So there is probably as many opinions as there are people on earth about mathematics, probably. And so therefore you can say that there is no way to decide whether this sentence is true or false. There is ambiguity there. And so you cannot mathematically, it's not a mathematically accepted statement. And you can say that, of course, this sentence is subjective. Can call this sentence subjective, meaning that it depends on people, in the sense that those who like mathematics, it may be fun for them, otherwise it may not be. That means that this sentence is not always true, and so it's not a statement. Now suppose that, for example, you say there is no rain without clouds. There is no rain without clouds. There is no rain without clouds. So again, I don't know much about rain and clouds and that sort of thing, but here what's written about this sentence is that it's a scientifically established natural phenomenon that cloud is formed before it rains. Therefore, this sentence is always true. Hence, it's a statement. Okay. And the next sentence that we have is, how far is Chennai from here? How far is Chennai from here? Now the word here in this sentence makes it impossible for us to decide whether to basically, first of all, it's a question, right? It's not even a statement, or it's not even a sentence. It's a question. And moreover, there is the word here in there in the sentence. So it's even not possible to answer the question because I don't know where here is. So if you told me that, for example, how far is Chennai from Kolkata, for example, I could basically check on the internet somewhere, somehow decide the distance between, for example, Chennai and Kolkata. Otherwise, but again, this is again a question, and we said that questions are not considered as statements in mathematics. So it says that this is a question which also contains the word here. So you have two problems here. Here you have two problems in this sentence. First of all, the word here, and then second, the fact that this is a question. So hence it's not a statement. So that's basically how you decide. Whether a sentence is a statement or not. Okay, so now in the next video we will talk a little bit about exercise. We can do it over here as well. Okay, so for example, let's say that you have this is exercise 14.1. This is exercise 14.1. So you want to decide which of these sentences are statements, and we need to give reasons for basically for the answers that we provide. So number one is there are 35 days in a month. There are 35 days in a month. So first of all, since there are different types of months depending on the number of days in the month, you need to specify which month you're referring to, but you haven't. But the sentence hasn't done that. It's just they have just said basically in a month. But that doesn't really matter, because the longest month of any year, of a year basically, the longest month of a year has 31 days. 31 days. Now the number that has been given here is 35. 35 is anyway higher than the highest number of days in the longest month of the year. So that means that this sentence is false anyway, meaning that you can decide that the sentence that the sentence is false, and therefore you can call it a statement. Therefore you can call it a statement. It is meaning that it is possible for you to decide whether the sentence is true or false. That's important. If you can decide that, then there is no ambiguity there, and then you can call it a statement. Otherwise, if there is ambiguity there, you will not be able to decide whether the sentence is true or false, and then it will not be called a mathematically acceptable statement. Let me check my answer over here. 14.1. So this is a statement. Now number 2 is basically a sentence that says mathematics is difficult. Mathematics is difficult. Now when you say mathematics is difficult, this sentence, you can call it a subjective sentence. A subjective sentence, not in the sense of grammar or language or things like that, but basically the fact that the sentence says basically mathematics is difficult, this is a subjective view of some person. Meaning that it differs from person to person. Some people think that mathematics is difficult. Some people think that mathematics is not difficult. So there is no way to decide, and there is really no standard there. There is no scientific procedure to decide whether mathematics is difficult or not, and there is no definition for difficult. I mean, there is of course a definition for difficult, but there is no way to decide whether mathematics is difficult or not, because again the sentence is subjective. For some people mathematics is difficult, for some people it's not. So you cannot decide whether this sentence is true or false, therefore it's not a statement. Therefore it's not a statement. Now number 3 is the sum of 5 and 7 is greater than 10. The sum of 5 and 7 is greater than 10. So you know that the sum of 5 and 7, you know that 5 plus 7 is equal to 12, and 12 is greater than 10. So that the sentence, you can decide that the sentence is true. So you can call it a statement. You can call this a statement. Number 4, the square of a number is an even number. Number 4, the square of a number is an even number. Now about this sentence, for example, you see 1 squared is equal to 1, 2 squared is equal to 4, 3 squared is equal to 9, 4 squared is equal to 16. So you see that these numbers, this is the square of 1, this is the square of 2, this is the square of 3. So it's sometimes 5 squared is equal to 25. So it seems that basically, alternatively, you get basically an odd number, an even number. An odd number, excuse me, you get an odd number, an even number, and so on and so forth. So of course the statement or the sentence is false. It's easy to see that the sentence is false. And so you can call these statements. So you can call these statements. So number 4, let me check my answer. 14.1, number 4 is sometimes true, sometimes not true. For example, the square of 2 is, I see. Well, there is something else about true or false, but I think that definition doesn't apply here. There and based on I did decide this based on that definition, and that definition seems to be not the case or not be that important here. So I don't understand why. Well, that definition of true and false is that we say something is true if it is true all the time. If that thing is false even one time out of all of the instances of that thing, then you call it false, meaning that for example, in the case of prime numbers, we say that, for example, you know that 2 is a prime number, 3 is a prime number, 5 is a prime number, 7 is a prime number, and so on and so forth. So these are the list of prime numbers. Now, based on the definition that I'm talking about, if I say that, for example, all prime numbers are, for example, are odd, of course there is 2 over here, and because there is this 2 over here, this statement becomes false. Basically considering the fact that all of the other numbers that you would get over here, they are all odd numbers, but there is only one even number here, and this one even number makes this statement false. But that definition seems to be not important here for whatever reason, and so the reasoning that has been used here is that it says that number 4, this sentence is sometimes true, sometimes not true. For example, the square of 2, meaning 2 squared is equal to 4, which is an even number, and the square of 3 squared is equal to 9, which is an odd number. Therefore, it is not a statement, meaning that since sometimes you get even numbers, sometimes you get odd numbers, it's not possible to decide whether this is true, or maybe basically the definition of true and false will follow, but let's see how it goes. I'm not really sure about, because based on what I have read before, the definition of true and false is basically what I just said, but that seems to be not the case here. Here again it says that this sentence is sometimes true and sometimes not true. For example, the square of 2 is an even number, and the square of 3 is an odd number. Therefore, it is not a statement, meaning that since you sometimes you get an even number and sometimes an odd number, so you can say that this sentence is sometimes true, sometimes not true, and so you cannot decide. Let me see over here. So in the definition that we had over here, we said that a sentence is called a mathematically acceptable statement if it is either true or false, but not both. But, well, true and false have not been defined here. Now again, the reasoning that has been used here is that basically this statement, this sentence is sometimes true and sometimes not true. Therefore, it is not a statement. So you can say that the sentence is sometimes true, sometimes not true, therefore not a statement. Okay, so that is that. Now question number 5 is the side of a quadrilateral have equal length. The number 5 is the sides of a quadrilateral have equal length. Well, you can use the same reasoning here as well, meaning that you can draw a quadrilateral, for example, a square, and you know that in a square, if this side is equal to this side is equal to this side is equal to this side, then this sentence is true. But on the other hand, you can draw a quadrilateral like this, and so this side, of course, these sides are not equal in length. So then you can say that this is sometimes true, sometimes not true, and therefore you cannot call it a statement. But it's important to see what sort of reasoning they have used for this, because based on the reasoning you can, well, see what sort of reasoning must be used in these cases. Otherwise, so it says that this sentence is sometimes true and sometimes false. For example, squares and rhombi have equal length, whereas rectangles and trapezium have unequal length. Therefore, it's not a statement. Okay, the same type of reasoning as for this one over here, right? So question number 6 is Question number 6 is answer this question. Answer this question, which is just basically simply an order. An order is not a statement. So it's an order and not a statement. Not a statement. Number 6, it's an order and therefore it's not a statement. Okay. Number 7, the product of -1 and 8 is 8. The product of -1 and 8 is 8, which is, of course, the sentence is false, and therefore you can call it a statement. You can call it a statement. So number 7 is the sentence is false as the product is -8, therefore it's a statement. Okay. And number 8 is the sum of all interior angles of a triangle is 180 degrees, which is the sum of all interior angles of a triangle is 180 degrees, which is, of course, the sentence is true, and so you can call it a statement. Number 8 is statement. Number 9, today is a windy day. Number 9, today is a windy day. Now there is no way to decide whether this sentence is true or not, because you don't know what today is. You don't know what today refers to. There is ambiguity there. So this is not a statement. It is not clear from the context which day is referred, and therefore it's not a statement. And number 10 is all real numbers are complex numbers. Number 10, all real numbers are complex numbers. Of course, there are some real numbers that are complex numbers. Complex numbers are basically the kind of numbers that you have basically a plus bi, for example. A plus bi, that's a complex number. And so when you say all real numbers are complex numbers, of course there are some real numbers that are not complex numbers. So this is of course false if the sentence is false, and so it's a statement as far as I can understand. So this is a true statement because all real numbers can be written in the form a plus, well, that is right. That is right. This is not false actually, this is true, because you can write all real numbers in the form basically complex numbers are basically written in the form a plus bi. Now you can write all real numbers in the for all real numbers. You can assume that basically your b is equal to 0. You can assume that your b is equal to 0, and so your number becomes basically a plus 0 times I, and so that becomes basically that you can write it as a, right? And so that becomes a real number. So basically then when you say that, basically then you can say that, of course, all real numbers are complex numbers. That's true, and so that means that this is a statement. This is a statement. Now, there is another part to this question that says give 3 examples of sentences which are not statements. Give reason for your answers. Give 3 examples of sentences which are not statements. For example, I don't know, if you say, for example, I don't think we need to we have already done enough examples here. So I will end this video here, and then we will do the rest in the rest of this chapter in the next video. I'll see you in the next video.